Good afternoon. I'm Suresh Patnaik. Welcome to 66th meeting of Think Tank. Madam has asked at the beginning to our chief guest, what is the weather prediction today? And I was just going through the Google prediction. That is today will be, I think, isolated storm and storm shower, and then cloudy and 10% rain. We are all curious to know about this, and we believe the predictions nowadays. But you may kindly remember your childhood days, where we are familiar with the weather forecast there, and then nobody believed this. Nobody took it seriously. In fact, some jokingly used to say that she's reading the weather forecast by looking out of the window only. And then if somebody is making a confused statement, people used to say, don't talk like don't talk like that. So this was the condition in those days, sir. And then, joke apart, there was hardly any time warning in those days on flood, cyclone, or any other natural disaster. When 1971 cyclone struck Odisha coastline, thousands and thousands of people were washed away while sleeping. Many of us must have witnessed this, and or might have read it. During that time, a boy of 6 of a small village, Rajgurupur, near Ghanteshwara of the present Bhadak district, was the direct victim of the ferocity of that cyclone. He and his family had to live on the wheat distributed by the government instead of paddy, as for about a year, as all the paddy fields were submerged. Nobody, moved by these miseries of the people around, the young boy took some sort of a vow to tame the cyclone one day and reduce its devastating effect. And he did so. And that man and that boy was no other than the chief speaker of today, Dr.Mrutyunjaya Mohapatra, Director General, IMD. Like Sridharan, we know as a metro man for his metro project, Dr. Mohapatra is fondly known as the Cyclone Man. A proud son of Odisha, Dr. Mohapatra is a homespun scientist of national and international repute. After his schooling at his village and high school at Ghanteshwar, he graduated from Bhadra College and did his PG and PhD in physics from Utkal University. Initially, he joined an Agni program of Chandipur under the stewardship of Dr. Abdul Kalam. But he did not forget his childhood commitment and joined in Indian Meteorology Department during 1992. During 1999 super cyclone, sorry, just a minute. Okay, during super cyclone, he was posted as regional director of Bhubaneswar. And you know, in those days, the warning was only for a few hours, and Odisha was more or less caught by surprise. And you know the devastation. And Dr. Mohapatra was, though there was, but he was undone in those days. Assessing the problem, considering the problem of those days, the IMD took up the measure of renovation of the IMD equipments, and then Dr. Mohapatra was shifted to Delhi to modernize the equipment. And with his leadership, now you have gone foreign, you have got every year after year, the cyclones were visited by Odisha, and he had accurately projected the trajectory, the landfall, the velocity of wind velocity, the height of this waves, everything he could predict it near accuracy. So there was the immediate and appropriate actions could be taken. Evacuation, everything was done, and then Odisha is recognized as one of the uh, model state for disaster management. And then she was also recognized by the UNO. And so the chairperson is now with us. And then he has got so many accolades, so many prizes from IMD and then all other departments. And then his passion to for his research work, for his innovation, and for his modernization, and he has a long way to go. And then he will have lot of more accolades to achieve. And we wish him all success. And then welcome, sir, Dr. Mohapatra. And then we are here to listen to you. You can speak for about whatever the time you want to take, either 40 or 45 minutes. And then I request our participants to kindly switch off their mute the mute, and then put whatever the questions through the chat box. And then after the end of the speech of Dr. Mohapatra, he will address those questions. I will read out, or he himself will take up, and then we will interact in the close participation. And then and now as usual, our revered president of think tank, Dhiren Kumar D.K. Rai, will preside over the meeting, and I welcome him, sir. I welcome everybody once again. Thank you.
Namaskar, D.K. Rai Kochi. In fact, on behalf of all the distinguished members of think tank, I must extend a very, very warm, I have the privilege of extending a warm greeting to Dr.Mrutyunjaya Mohapatra, who is the most important man in today, and in fact, Dr. Mohapatra is a homegrown scientist, as Suresh has said, but I think he has reached the peak in which Odisha is proud of having him at the top of the meteorological department, meteorological hierarchy in the country. In fact, now he has got a great name. He has got a great name and fame, and we are all proud of him. And we are here mainly to listen to him, because this is a weather forecasting used to be a very esoteric thing. I remember that about 60 years back when I was in Moscow, when they used to say that tomorrow there will be no rain, or tomorrow this thing will happen. We used to feel that it is something from the fairyland. But now today in India, in Odisha particularly, we are now hearing and very reliable forecasts. And maybe we are not going to conquer nature, but we have to predict the nature and then to have the mitigation of whatever devastation it has to do, climate has to do. So, Dr. Mohapatra, we are all here to proud of you, and we will listen to you. Please kindly tell us, because the credibility of the meteorological department, meteorology, is increasing day by day, and the dependence on it also is increasing day by day, whether it is a question of agriculture or whether a question of livelihood, or whatever it is the meteorological predictions, weather forecasts, and also mostly because Odisha is so much prone to the devastations, and Odisha is one of the most worst affected as far as the natural calamities are concerned, and therefore for us it is the most important aspect, and we are assured that you are at the top. So thank you, Dr. Mohapatra. So we welcome you once again, and I'm sure that we will listen to you, and then we will take note of whatever you say, and I'm sure you will take care of the concerns that we have in this gathering and also in the state of Odisha. Thank you. So welcome, Dr. Mohapatra. I will now hand over the stage to you to please speak to us and give your words of wisdom. Dr. Mohapatra.
Namaskar. Respected President, Think Tank Odisha, Mr. D.K. Rai. Respected Secretary General, Think Tank, Dr.S.K.Tamotia. Respected Swadesh Patnaik sir, and distinguished members of the Think Tank present here. At the outset, I feel myself obliged and grateful to all of you for giving me an opportunity to speak and to be associated with your blessings. I am a too small person to speak in front of such an august gathering, an expert who can lead, who can think and guide the persons like me. So really, speaking from my heart, I'm really blessed to be associated with all of you and get your blessings. So I have been asked to discuss about the early warning for weather and climate hazards in Odisha. And I will be speaking about that. Before that, I'll just have some kind of a general discussion about the weather and climate systems. I hope the screen is visible.
Yeah.
I moved to the second screen, second slide. Is it moving? I have moved to second slide. It is moving.
Yes,
Climate
yes,
system.
Yes, very much, very much.
Fine, sir. Thank you, sir.
That's number 2, yes.
Yes.
So when you consider the weather and climate system, whether, as Priyamada Madam was asking, whether it will rain or it will not rain tonight in Bhubaneswar, or whether monsoon will be good this year or bad, or whether there will be heat wave or whether there will be thunderstorm. So this type of weather and climate systems are just a byproduct of the interaction among the various forces and various processes arising out of the Earth system. When I say Earth system, it includes the land, ocean, atmosphere, biosphere, and cryosphere, many more. So all these components of the Earth system interact with each other by many nonlinear ways, resulting in various types of phenomena, and weather and climate is such a phenomena. So if you just look at the various types of weather and climate systems which develop because of this interaction among the various components of this climate system or Earth system, you will find that there can be very small weather event like a dust devil, just like we might have seen while sitting outside of our house, small straws and dry leaves, just rotating anti-clockwise and going off. So that type of dust devils we can see. And gradually we can see sometimes, just like a cauliflower, some kind of cloud is developing in front of us in the sky, which is called as Cumulus Cloud. And sometimes that Cumulus Cloud goes up and it looks like a very tall cloud, cylindrical in nature. At the top, it is moving towards one direction, that is the cumulonimbus clouds or severe thunderstorm clouds. But if you visit sometimes Europe or USA, you will find that there the weather is very systematic. It just moves one after another. Sometimes there will be cold fronts and sometimes there will be warm fronts. So these are the frontal systems. Sometimes there will be some kind of extratropical cyclones. And these systems which develop over northern part of USA, Europe, in the extratropical latitude, they usually move very systematically and they are more predictable as compared to the weather systems developing over the tropical region. The basic difference between these systems, as I discussed, first 3, which basically develop over the tropical region, and the fourth one, which I was talking about, the cold fronts and warm fronts, which develop over the extratropical region. The difference is that basically the systems which are developing over the tropical region are based on the convective process. That means the heat energy is transferred between the surface and the upper atmosphere by the 3 processes: conduction, convection, radiation. And process of convection is dominant, just like boiling of the rice in a pot over the stove. So here also the particles move the process of convection and transfer heat and moisture from one part to the other part. Whereas in the extratropical region, the weather system developed because of the difference in temperature over the region. While these cumulus convective systems are short-lived and time is quite less and size is also quite less as compared to the frontal systems. So therefore, their detection, monitoring, prediction become too difficult as compared to the frontal systems occurring in the extratropical region, especially in northern parts of USA or UK or European countries. So therefore, sometimes when people visit the foreign countries and they come back to India and they find that there is a difference. Yes, certainly, there are two types of differences. One is the difference with respect to the science itself, the genesis of the systems itself. And the other one, of course, the capability, the technological development in the country as compared to the Western countries. So if we just move on, you will find that there are systems called as high pressure cells and low pressure cells. The low pressure systems also develop basically over this tropical region. And these low pressure systems are the major rain-bearing systems. And sometimes these low pressure systems intensify, becoming depressions and cyclones, causing the loss of lives and properties wherever they go. These low pressure systems basically form during the monsoon season here, June to September. About 13 low pressure systems develop in our region. But at the same time, we have got two more seasons. One is the pre-monsoon season, March to May. Other one is the October to December. In these two seasons, which are called as the cyclone seasons here, the low pressure systems develop over Bay of Bengal and Arabian Sea, and they become the cyclones and affect the regions. So thereafter comes the more larger weather systems that is called as water circulations, that is the large-scale wind pattern over the tropics and the extratropics, which govern the various weather systems formation over the period of time. Then we have the variation. This water circulation leads to variation from year to year, while monsoon is a variation within the season itself. So when you go beyond water circulation, that is the variation within a year, you come to variation from decade to decade also. So we talk about climate variability, and finally nowadays also we talk about the climate change or the global warming, which takes place over a period of, say, 100 years or more. So therefore, the weather and climate systems can vary as small as about less than 1 kilometer, that is the microscale systems, to a synoptic scale systems like the low pressure systems and mesoscale systems like thunderstorms. And you can have the large scale systems like monsoons. At the same time, you can have in the time scale, the very small systems like a thunderstorm occurring for about a few minutes or half an hour or 2 hours. And you can have a low pressure system with a life period of about 5 days. Then of course you can have monsoon with a life period of about 4 months. Then of course you can have the interannual variations, which goes about the decadal years following certain activities in the astronomical features. For example, the sunspot cycle or something else. So therefore, there are different weather and climate systems with different spatial scales and the temporal scales. So if you just look at the weather systems which become the hazardous or disastrous over the Indian region, you'll find that India is such a country that it experiences all types of hazards. It is experiencing tropical cyclones, as you can see in the top left, this is of the tropical cyclone filing. And then you can see the tracks of the tropical cyclones on the right-hand side. About 5 cyclones develop over the Indian region, 4 over Bay of Bengal and 1 over Arabian Sea. And these tropical cyclones usually move northwestwards, and therefore Odisha and Andhra Pradesh are the major target for the tropical cyclones developing over the Bay of Bengal. Then this next picture is the cyclone hazard proneness over the country. You can find out East Coast is more prone, as you can see from the before diagram here. The number of cyclones are more over the Bay of Bengal, and hence East Coast gets more affected compared to the West Coast. And among the East Coast, Odisha and Andhra Pradesh are the most affected states because of the tropical cyclones. Here we have gone for some kind of hazard proneness mapping for different coastal districts. You will find that North Odisha districts are most prone districts along with the West Bengal districts. It is also the most prone over the central part of Andhra Pradesh. Next one is this is the mapping of the earthquakes. You can find this Odisha, some parts of Odisha extending from central part across Bhubaneswar. Also, you have got the zone 3, so it is prone for the thunderstorm activity passing through one whole area. And then also this region experiences monsoon, and as all of us know, 70 to 90% rainfall over the country occurs because of the monsoon. And in Odisha also, the monsoon rainfall dominates in the year. And this variation in monsoon, you will find that it is not uniform. It is quite random over the years. So therefore, it can lead to floods. It can also lead to droughts. Just for example, this year, you have got very good rainfall activity in most parts of the country. Out of 36 meteorological subdivisions, we have got 28 meteorological subdivisions where it is excess to normal rainfall. But there are 8 subdivisions which have got deficient rainfall, and Odisha is one of them. So far, Odisha has become deficient in rainfall activity about 28%. So as a result, you can have sometimes the floods and droughts. This map in center, you can find out this red zoning is the flood-prone zones of the country. And we have the flood-prone zones across the coastal areas and some other parts. Similarly, there are the drought-prone areas in the country. You can find out in Odisha also, there are certain pockets which are prone for the droughts. So apart from all these large-scale phenomena, also we experience very small scale, like thunderstorms, hailstorms, squalls, tornadoes in the country, and also in Odisha. And these are some of the mappings. You can find out that the frequency of thunderstorm is quite high over the northeastern states and eastern India, including North Odisha. And popularly, it is called as Nor'wester or Kalboisakhi. So these are some of the pictures shown here, how the thunderstorm occurs and how the hailstorm occurs. I'm not going to discuss details about it. I just want to say that all of us know that our region is prone for thunderstorm activity, including hailstorms, squalls. Tornado also occurs in our region, though it is quite few. Now, before I proceed for some of the natural hazards occurring over Odisha, I just want to mention here how Odisha is physiographically different from one part to the other. You can find out all types of variation with respect to physiography. We have got the coastal plains, also we have got the northern offlands, and also we have the Eastern Ghat region in the southwest Odisha. And we also the riverine plains. You have got the major rivers like Mahanadi, Brahmani, Baitarani, Suvarnrekha, Bhavan, of course, Vamsadhara and Risipulya, and all their branches and tributaries. So this variation in physiography also leads to the role of land surface processes, modifying the weather pattern over the region and sometimes the hazards. So if you just look at that, for Odisha is frequently prone to the natural hazards like thunderstorms and associated weather, floods and droughts, heat waves and cold waves, and cyclones. So you may think of why I have kept thunderstorm at the top and cyclone at the bottom. It is because it has been reversed now. The cyclone was is the most important killer about, say, 20 years back. In 1999, 10,000 people died because of the cyclones. But at present, if we just look at the number of deaths due to cyclones have been reduced to only to double digits, sometimes to single digits. So therefore, I thought I would just reverse the order, and the topmost order is now the thunderstorm and the because the number of deaths, if you just look at per year, is about 2,500 to 3,000 people in the country because of the thunderstorms and associated lightning, especially. So therefore, the major target now is to minimize the loss of lives from thunderstorms and lightning. At the same time, also the floods and droughts are part and parcel of India and also Odisha. Even if it is an excess rainfall year, you will have the droughts in certain parts. And even if it is a normal year or deficient year, also you will have the floods in certain parts. It also happens every year in Odisha because Odisha, I used to say to the people that it is the gateway to all types of natural hazards. Because of its physiography, because of its geographical location and adjacent to the sea and the meteorological patterns, you will find that every year you will have all types of hazards in Odisha. So it is, if you consider the monsoon season, especially what happens, there are 13 low pressure systems developed over the monsoon season. And these monsoon season low pressure systems are the rain bearing systems. If they move along the monsoon trough towards west-northwestwards, Odisha gets good rainfall and leads to floods. And if these low pressure systems do not form over North Bay of Bengal and they do not move northwestwards, then Odisha does not get good rain, which has been this year. There has been 4 to 5 low pressure system development in the second half of July and in the beginning of August. As a result, there has been good rainfall activity to some extent, but remaining period, Odisha could not get good rain, and it resulted in deficient rainfall for the state this year. So therefore, ଓଡ଼ିଆରେ କହନ୍ତି ଯେ ଜଳ ବହୁଳେ ସୃଷ୍ଟିନାଶ ଜଳ ବିହୁନେ ସୃଷ୍ଟିନାଶ ଓଡ଼ିଶାରେ ଏଇଟା ବହୁତ applicable because we do not get good rain if there is no low pressure and we get very good rain if there is no pressure. So either you get floods or you get droughts very often. And of course, the cyclones, we get almost affected every year by at least one cyclone. So here you can just find out some statistics. I am not going through that. We get thunderstorm, tornado, gales, squall, everything. So therefore, Odisha is a multi-hazard state. You can find out all types of hazards, especially in the coastal belt. If you just look at, you will have all types of hazards, which are mostly hydrometeorological in nature. Now, just coming to the tropical cyclones which affect Odisha, you will find that Odisha is the most prone state for the extremely severe cyclone storm. If I compare the frequency of extremely severe cyclonic storms crossing different states of India, you will find that, or even Bangladesh or Myanmar, you will find that Odisha experiences most frequent extremely severe cyclone storm. We have also the notorious record of the super cyclonic storms. And that super cyclone storm which crossed Odisha on 29 October 99 is so far the most intense cyclone in recorded history of India Meteorological Department. We have got the data from 1877 onwards. So during this data, we find that this is the most intense cyclone which hit on that day. So what you find actually the total frequency of the cyclones is decreasing over the Bay of Bengal. And but the extremely severe cyclone storms are not decreasing. They are almost same. And number of extreme severe cyclone storms crossing Odisha is also not decreasing. It remains same. So what I want to say that even though the marginal cyclones are decreasing, the vulnerability due to the extremely severe cyclone storm stands. And as the number of population increases, the socioeconomic activity along the coast increases, therefore we are becoming more and more vulnerable to the extremely severe cyclone storms over the years. So this is the same diagram, but it is the cumulative figure of the cyclone storm, all types of cyclone storms taken together. And similarly, all types of extreme severe cyclone storm, very severe cyclone storm. CS means cyclone storm, SCS means severe cyclone storm, VSCS means very severe cyclone storm, ESCS means extremely severe cyclone storm. These are defined based on the wind speed associated with the cyclones. When wind speed is 60 to 90 kmph, it is called a cyclone storm. 90 to 120 means very severe cyclone storm. Severe cyclone storm. 120 to 160 is the very severe cyclone storm. 160 to 220 is the extremely severe cyclone storm. More than 220 kmph is called as super cyclonic storm. So what we did actually, we have gone for some kind of hazard proneness or mapping. So when cyclone approaches a particular coast, it causes the heavy rainfall, it causes the winds, it causes the storm surge and tidal inundation into the low-lying areas. So therefore, the hazard proneness of a particular district not only depends upon the frequency of cyclones, but also depends upon the associated weather like heavy rainfall, wind and storm surge. So we did this mapping and we found that there are certain districts which are more prone. For example, Balasore, Kendrapada, Jagatsinghpur, Bhadrak districts are the topmost prone districts. We call it as very highly prone districts for the cyclones, followed by Ganjam, Puri, Khurda. And also we have got districts like Mayurbhanj, Cuttack, Nayagarh, Gajapati, Jajpur and Keonjhar, also prone for the cyclone impact. So this is accordingly, this is the frequency of severe cyclones, this is the frequency of total number of cyclones, and according this is the frequency of wind speed affecting different regions. This is the probable maximum storm surge, the height of the tidal water which inundates the coastal area, and this is the amount of rainfall which occurs over the area when cyclone crosses the coast, and this is the multiple impact and index-based donation. This donation is used by Government of Odisha and Government of India to construct the houses and shelters in the coastal belt. So considering the flood hazard map, you will find that there are the flood zoning across India, and there are zones where it's very highly prone, moderate, low, etc. But about 7.2% of the area is very highly prone for the floods, etc. It has been prepared with the help of NDMA and NRSC, and it is used by OSTMA also. So similarly, if you just look at, it does not mean that other part of the country, apart from whatever shading is there, does not experience the floods, also experience the floods. So therefore, the entire Odisha, you can say flood prone, but this coastal belt is more prone for the floods because of these river systems. Now, if you just look at the rainfall, whatever occurs over Odisha, you will find that total amount of rainfall in a year is about 145 centimeters, and during monsoon season, it is roughly about 115 centimeters. So therefore, the monsoon rainfall is dominant in the total annual rainfall budget of the state. And we get very less rainfall during monsoon, but sometimes we get winter rainfall because of western disturbances passing over the region. Otherwise, during month of March, April, May, we get rainfall, especially due to the cyclones or otherwise due to the thunderstorm activity. In the post-monsoon also, we get rainfall because of the cyclones or the withdrawing monsoon during that phase. If you just look at the trends of Odisha rainfall, you will find that there is no trend. This is the rainfall from 2018. You will find that rainfall is random in nature and there is no trend. It is trendless for Odisha annual rainfall and also for southwest monsoon rainfall. It is a good news for Odisha that Odisha rainfall is not changing over the years. But if you just look at the rainfall during monsoon season over different districts, the picture is different. So earlier one, what I showed you, that is the average rainfall for Odisha as a whole. But this picture is on the right-hand side. I will be showing some pictures here. On the right-hand side is the average rainfall distribution during monsoon season. It is based on the data of 60 years, 1950 to 2010. And on the left-hand side, this is the trend analysis, whether rainfall is increasing or decreasing. The deep red color, what you find, that indicates the decreasing rainfall scenario, and deep blue indicates the increasing rainfall scenario. So what you find actually in the southwestern region, there is a mixed trend, while the Malkangiri, Koraput, and Gajapati district indicates there is decrease in rainfall activity, and you have got Raigada district increase in rainfall activity. So, but in general, if you just look at most of the districts do not show any significant trend, but there are a few districts, especially the southern part and northwestern part, where there is a trend of decreasing rainfall. Now, similarly, if you just look at the annual rainfall, since monsoon rainfall contributes about 80 to 90%, therefore annual figure almost is the reflection of the monsoon rainfall. So therefore, you can find out that there is a decreasing trend in the western part of Odisha in the annual rainfall, and also extreme southwestern part. So this is the figure at present. And if you just look at the distribution of rainfall during the season itself, you will find that nowadays the number of days of occurrence of heavy rainfall, that means rainfall more than 150 millimeters in 24 hours, are increasing. At the same time, the number of days with light rainfall or moderate rainfall are decreasing. So this is the left-hand side figure, shows that what is happening across country. You will find that starting from Gujarat towards Odisha and West Bengal, across Madhya Pradesh and northern part of Maharashtra and Chhattisgarh, what you find actually, these red dots, the orange dots, you can say, orange dots and yellow dots, these are the increasing trends, and you don't find any blue dots. So orange dots are significant increasing trend in the frequency of occurrence of the extreme weather events, that means extreme rainfall events during monsoon season. So what I want to say that Odisha is experiencing the increase in frequency of the occurrence of the extreme rainfall events also. On the right-hand side also, you can find out there are certain pockets where you have got the increase, and there are certain pockets where a decrease in the frequency of heavy rainfall event. On the right-hand side, heavy rainfall event starts with 7 centimeter and above. The blue indicates, blue arrow, downward arrow indicates significant decreasing, and red upper arrow indicates significant increasing. So what you find here, that frequency of heavy rainfall events across the central part here in northern, you have some decrease, but there are certain areas here in the eastern Ghat area of the southwest Odisha, and also some parts in western Odisha, you have the increasing trends. Now, if I just look at number of rainy days means when there is a rainfall of at least 2.5 millimeter per day. So what also you find that there is increasing trend in certain parts and there is a decreasing trend in certain parts. So that means what you find is there is a mixed scenario over Odisha. As a result, the total amount of rainfall does not show any trend for Odisha state as a whole. But if you just look at the total number of dry days, you just see in the right-hand side here, for the total number of dry days, there is no rain. So it is increasing across the state. You find that total number of dry days is increasing in the year as a whole. But if you consider only monsoon season also, there also you find that many stations are reporting increasing dry days. So Odisha is in agreement with the entire central part of the country that number of dry days are increasing, and also number of extremely heavy rainfall days are also increasing, but number of light rainfall days, number of moderate rainfall days are decreasing. That means the state and central India is becoming more vulnerable to the flash floods, all of a sudden, with a decrease in ground percolation, and hence groundwater recharge also likely to decrease, and which I've seen with the observations also. If you just look at the temperature, you find that winter temperature of Odisha is showing some kind of, this is the temperature, minimum temperature, which is a measure of the coldness during winter. So what do you find that actually there is some kind of increasing trend in the extreme northeast Odisha, like Bhavan, Bhalasur and Bhavan districts, and otherwise there is no trend. So that means winter minimum temperature is not changing. It is almost trendless, except extreme northeast Odisha where temperature is rising, which is expected also because of the global warming in the general. There should be the rise in minimum temperature. But that doesn't mean that everywhere temperature will rise. This is the case with Odisha. Now, if we just look at pre-monsoon season, usually we experience heat wave conditions. Before that, I just want to say that when you saw minimum temperature, usually northwest Odisha experiences cold wave condition, and sometimes it extends to the central part of coastal Odisha also. The good thing is that the temperature is rising here, and therefore the severity of cold wave is decreasing over Odisha. Whereas heat wave condition, if you just look at which occurs in the monsoon season, that is March, April, May. So what we find actually, there is a rise in temperature. You see how many districts are showing on left-hand side diagram, how many districts are showing red color. So almost 50% in the south, you have got rise in temperature. Once you've got rise in maximum temperature, that means the state is becoming more prone for the heat wave conditions. If there is rise in mean temperature, there will be increase in frequency of heat wave and severe heat wave conditions. So this is the monsoon season. If you just look at monsoon season, entire state shows the significant rise in the temperature. So this rise in temperature during monsoon season helps in occurrence of extremely heavy rainfall event when a low pressure system passes over Odisha. So that is why the extreme weather events like extreme heavy rainfall is increasing not only over Odisha, but also the central part of the country. It is mainly because when the temperature rises, this temperature rise is not limited only to the surface, but also it extends up to the entire troposphere. So therefore, due to this rise in temperature in troposphere, the water holding capacity of the atmosphere increases, or moisture holding capacity of the atmosphere increases. So you have got more evaporation because of rising temperature from the sea, rising temperature in the water bodies. At the same time, you have got the more water holding capacity of the atmosphere. Therefore, as and when it gets the chance to rain, so rainfall becomes quite high. So therefore, it does not rain, and whenever it rains heavily during monsoon season. So this is the annual rainfall. This is just representative. Annually also, the maximum temperature is increasing over Odisha. So if we just look at minimum temperature, you have got a mixed trend here. So therefore, the impact of global warming is not seen much in terms of the minimum temperature. It is seen more in terms of the maximum temperature. So if you consider the mean temperature, that means average of maximum and minimum temperature. So obviously, the maximum temperature dominates, and you get a rise in temperature. Now, if you just look at the impact of this rise in temperature because of various phenomena, including global warming, what you find actually, there is the heat wave, which is experienced over different parts of the country. On the left-hand side diagram, you can see that this red zone is the zone where you experience heat wave days. So starting from Rajasthan off to North Odisha, you see this region is prone for heat wave activities, central and North Odisha. So if we just look at the trends, what you find actually, This is, of course, a trend value is severe heat wave conditions. There is no such trend in certain parts. There is some increasing trend in certain parts. So similar is the case when you consider the number of heat wave days. That is the heat wave spells, and here is the number of heat wave days. So there is a mixed trend. But over this belt where we usually experience heat wave conditions in Odisha, there is a trend of a rise. So in this scenario, when you have got this type of impact, that means you have a naturally prone region like Odisha, which experiences all types of extreme weather. At the same time, the region is experiencing the climate change impact because of the global warming. So what should be done? Or what is the scenario then? So in this scenario, what happens whenever, I was just explaining a little before, whenever you have got rise in temperature, and that rise in temperature is extended to the troposphere, so the water holding capacity is higher. So therefore, what happens actually, it can lead to development of convective clouds, that cumulus cloud, which I discussed in the first slide, and that cumulus and cumulonimbus clouds have the capacity to cause the rainfall, to cause thunderstorms, etc. But the size of that cloud is very less. It is about less than a kilometer sometimes. And the duration of that cloud is about half an hour to 3 hours. So therefore, these clouds are difficult to monitor, difficult to predict because of their small temporal scale and because of the small spatial scale. So therefore, what happens actually when you have got the global warming, the predictability of these such mesoscale events like thunderstorms, heavy rainfall becomes less. The study shows that the predictability of these mesoscale events like thunderstorms and heavy rainfall has decreased because of this global warming from 3 days to 1.5 days. That means if you could have naturally predicted a weather event, say, Priyamoda madam was asking rainfall over Bhubaneswar today. If you have naturally predicted rainfall over Bhubaneswar 3 days in advance, because of global warming, now you will be limited to predict only 1.5 days in advance. But what to do then? So to tackle this situation, you have to go for emphasizing your observational network so that it can address that type of small-scale weather events like thunderstorms and heavy rainfall. So what to do then? So we have to go for increasing our observational network so that we can detect each and every mesoscale event like thunderstorms and heavy rainfall. We have to go for assimilating all this observational data into the mesoscale models or regional models, high-resolution models, so that you can give the forecast for every 1 kilometer because size of the cloud is 1 kilometer. You have to go for addressing the uncertainty in the model forecast. You have to go for addressing whether rain will occur or rain will not occur. If I simply answer to Priyamoda madam that it will rain today, then it may be correct, it may not be correct. But if I say that, yes, there is probability of rainfall about, say, 25%. And then madam might think of, okay, so today probability is less, but there is still some probability, but probability is less. So over the globe, therefore, what people are doing, taking into consideration this uncertainty in prediction of these mesoscale weather events, people go for providing the probabilistic forecast. So there is a need for quantifying this uncertainty, go for probabilistic forecast, and warning and distribution system has to be quick enough. So that means if I am finding immediately, because predictability has decreased, if I am finding immediately that there is a possibility of heavy rainfall, immediately I should inform the general public, disaster managers, press, electronic media, so that immediate action can be taken by the various users. So how will you do that? So for doing that, you need the capacity building the forecaster, disaster managers, media, and general public also. At the same time, if I say simply that rain will occur, that may not be sufficient, I should tell what the impact will be if the rain will occur. That is the impact. So in this direction, India is also moving forward to test the weather and climate hazards mitigations. When you go for chasing this, we have got the hazard analysis, vulnerability analysis, preparedness planning, early warning, and mitigations. And when I say early warning, it means skill in monitoring and predicting all types of severe weather, then effective product generation, warning product generation, and its dissemination to last mile. Then, of course, after predicting the weather, after disseminating, we have to coordinate with emergency response units. That means the disaster managers, say of district collectors or BDOs or tahsildars, or we have to coordinate with the industries and installations which are being affected by this type of weather. At the same time, we have to deal with general public in sectoral applications, for example, agriculture or tourism or aviation or maritime operations, and so many. We have to go for also the public perception. So if the public do not believe the forecast as what next I was telling in the beginning while introducing, those are the days when people did not believe at all because there was no credibility in the warning. People did not believe because there was no credibility. There was no confidence. If forecast was not consistent. So public perception was not good. But nowadays, if you just look at the public perception, they believe in the warning. We made a survey, independent survey. 95% of people believe in weather forecast and warning issued by IMD, especially the cyclone forecast. So taking into consideration also at the same time in the country, we have got the disaster management plan, we have got the disaster management institutes, we have got the institutional mechanism like NDMA, SDMA, DDMA, and on the right hand side that I've shown, and all these have ensured a response mechanism. The disaster managers have to respond during the pre-disaster, during disaster, and the post-disaster period by different types of actions. Okay, so what we do then actually, we go for a seamless forecasting strategy. So if I want to predict the heavy rainfall over Bhubaneswar, so it may not be possible to predict 7 days in advance or 15 days in advance or even 5 days in advance sometimes. So what to do then? So we can say at first, so whether there is a possibility of spell of rain, wet spell. So that comes from extended range forecast that is issued every Thursday for next 4 weeks. Then it is followed by everyday forecast for next 5 days, which provides the forecast at district level, telling that the possibility of occurrence of heavy rainfall or not. Now, when the day comes for occurrence of heavy rainfall, we go for every 3-hour forecast to give the update how much rain is occurring and how much rain can occur or how it will occur or not. Now, in this case, we go for impact forecast. We also inform what will the impact be. And to have a general planning, we provide the seasonal forecast, that is 1 season in advance. For example, monsoon season forecast is given on 16th of April this year and is updated on 1st June. Now, how to give this forecast? To give this forecast, we have a suite of models for different purposes. If I want to give the seasonal forecast of monsoon, we'll have different types of models. If you want to give forecast for a growth, we have the global models. And if I give the forecast for heavy rainfall or thunderstorms, the modeling is different. So we have got different types of models with different spatial resolutions and temporal resolutions. And all these models are being run with a high performance computing system. At present, the computing system which we have has the capability of 10 petaflop, and it is the 4th best in the world. And I want to say that at present, 7 numerical weather prediction models are run by IMD and Minister of Earth Sciences every day, twice at least. And some models are also run 4 times. Now, what happens actually, all these models differ from each other, just like doctors differ. So what we do actually, we go for some kind of system to compare, comprehend, analyze all types of forecast, and finally we issue a consensus forecast. So this is an example of the long-range forecast of monsoon. In the past days, we are issuing in the month of April, we issue the long-range forecast for the country as a whole and for different parts of the country. It is a history in the IMD or in the history of long-range forecast, which started in 1923. And the statistical forecast started in 1988. And dynamical forecast started in 2012. And this year, we went on providing forecast for each and every part of the country. What will the monsoon rainfall? I'll show the example afterwards. So past stage forecast we issued in the month of April on 16 this year. And this is a new initiative this year. The second stage we issued on 1st June. Then third stage forecast we issued by the end of June. And the past July issued the forecast. What will be the rainfall in July? Then what will be rainfall in August? Then what will be rainfall in September? So every month rainfall forecast is being provided. I just shown to one example. On left-hand side, on 16th of April, we issued this forecast for monsoon season rainfall over the country as a whole. Here, this yellow indicates the below normal probability of rainfall. And blue indicates the above normal probability of rainfall. So you can just see the 16th forecast, what we issued, 16th April, that was indicating that North Odisha especially will have that efficient rainfall. So you can see in general, Northeast India will have the efficient rainfall in some parts of Northwest India. And what we see nowadays that is happening to a large extent. Now, this seasonal forecast is followed by the extended range forecast for next 2 weeks. If you just look at this as an example, the blue color indicates above normal and yellow color again indicates below normal probability of rainfall. So this extended range forecast is issued for 4 weeks, but it is quite good up to 2 weeks. So up to 2 weeks, we can predict very well the occurrence of heavy rainfall spell or the wet spell, or occurrence of dry spell, or occurrence of heat waves, occurrence of cold waves, spells. And this extended forecast is also being issued specially for Odisha state. So this is just an example of the last extended forecast issued for Odisha in terms of rainfall activity. Now coming to the most important forecast, which involves the warning, that is called as short to medium range forecasting, and it is issued every day, twice from our Meteorological Center Bhubaneswar, and 4 times a day from the headquarters at Delhi. So what we do actually, I just want to explain a little. The weather forecasting is non-linear science. When I say non-linear science, that means this involves the non-linear mathematics. And this non-linear mathematics, if you just remember non-linear differential equations, these equations cannot be solved easily. So it has to be solved by the numerical methods, by iterations, etc., or interpolations. So there are many methods, or by fitting of the polynomials. So the numerical methods are applied. When you go for numerical methods, the basic concept in that numerical method is that you have to put the values, and that means data, and with the data, the solutions are established. And if you consider large volume of data, you can have the better solutions. If you have less data, you will do poor solutions. So this is the concept worldwide utilized in the numerical modeling. So therefore, what is done actually worldwide, people try to get as much as possible data, observational data, utilizing all types of platforms, observational platforms. And all these data are digitized, and then they are fed into various types of numerical models with the high-performance computing systems. The mathematical equations are solved, and solutions provide the current status of atmosphere, and then it is integrated to provide the forecast for various timelines. So in this process, we take observations from the surface, from upper air, and also from space, like satellites, radars, observation network, microwave radiometers, wind profilers, etc. Aircraft also. So all these observations, once it comes, the forecaster becomes in a position to identify the weather systems, their characteristics, their evolution, their impact. At the same time, the forecast generated from the numerical models are utilized by the forecaster to find out what will be the future scenario of the atmosphere and ocean and earth system. So to do this, forecast is equipped with the decision support system. That decision support system helps to compare, and analyze all types of observation and forecast and develop a consensus. That is the objective consensus forecast in different spatial and temporal scale. But after that also, there will be difference because models differ from each other. And also, when a forecaster decides, he also decides based on his knowledge, experience, and expertise. And the forecasters also differ, just like medicine specialists. So therefore, here what we do actually, every day at 10:30, we go for a video conferencing. And in this video conferencing system, just like it is done in case of a video conference among the doctors, even in the EMS. So here also, in case of a cardiac surgery or something like that. So here also, special video conferencing also carried out in the specific systems like tropical cyclones. But otherwise, every day we go for a video conferencing for 2 hours to exchange knowledge, experience, expertise on the analysis, interpretation of the model output and observations. And finally, the mathematical output available from the numerical model is converted in layman language. That is called public service or the end forecast. And this end forecast is different for different users. So for fishermen, the bulletin will not be same as the bulletin which is being issued by disaster manager like district collectors. Or a bulletin which is being issued to the port authority cannot be same as the bulletin which is being issued to a ship. So the bulletins are designed as per the requirement of the stakeholders, and accordingly, it is called as public weather service bulletin. And in this bulletin, we do not provide only the weather forecast, but also we provide the impact expected, the damage expected, and the actions to be taken by the disaster managers and general public. So, okay, so this is just another replica of the earlier slide. I want to say that what is the data flow? We have got entire observational network on the left-hand side. From here, it flows to the regional telecommunication hub. India acts as the regional telecommunication hub in the world. There are 6-7 hubs. And data are exchanged. You will be surprised to know that at present, within 10 minutes, we get all the data throughout the globe, which was taking about 3 hours when Odisha super cyclone was experience in 1999. Even that 3 hours data also may not be reliable because data are being exchanged by the telefilters, telex, telegrams, etc. So now this ICT has played a dominant role in exchanging the meteorological data and also the warnings. And finally, all these data are processed and they are provided to the forecasting systems, which are kept in 29 forecasting centers in the country. And Meteorological Center of Bhubaneswar is a well-developed center, which is responsible to provide weather forecasting running to Odisha state. And it acts as a cyclonic center. It acts as a flood meteorology office. It also has the earthquake detection system. It also provides all types of warnings with respect to weather and climate. And by that way, it goes to center, state, and media and general public. So this is the observational technique what we have in the country. You will find that India is well equipped, but still, if you look at the left-hand side diagram, you'll find that there are certain space. These are the radar network in the country. Basically, or optimally, a radar can cover an area of 250 kilometers to 300 kilometers, not more than that, because of the curvature of the earth and everything. But you will find that there are certain areas still left out where you do not have radar. At present, we have got about 28 radars from India Meteorology Department, 3 from Indian Space Organization, total 31 radars in the country. But still, country is not covered, and we are planning for around 15 radars during the next 2 to 3 years, so that entire country gets covered. Of course, we have got the satellites, INSAT 3D, INSAT 3DR, and we have got scatterometer satellite. We have got the observational network across the country. You can see from the right-hand side diagrams. It is well defined, and all these observations provide very valuable information, not only the forecast to determine the real-time weather systems, but also it goes to the numerical models to find out the forecast for next 5 to 7 days. So if you just get the observations in Odisha, you will find that we have got also a very good observation system. Accordingly, the daily observation summary is provided to general public and interest offenders on real time. This is just an example of observation summary being provided on daily basis. Now, based on this, as I was telling, impact-based information is provided. When you go for the impact-based forecast, there is a combination of 2 types of wedges. One wedge is the weather information provided by the IMD. Other one is the information about the mitigation strategy, about the socioeconomic conditions, about the secondary and tertiary hazards. So when these 2 wedges, as shown here in green and yellow, they mix with each other, then it becomes the impact-based forecast. That means I am telling that we provide what the weather will be instead of what the weather will do. So what we do then, we go for transforming the weather information into the impact estimation and also the response scenarios by the various responders. So this is an example of what cyclone forecast is, and I think all of us know, so I will not discuss in detail. I just say that India is recognized as one of the centers in the world to provide, one of the 6 centers to provide the cyclone forecast to all the countries in Bay of Bengal and Arabian Sea region. You'll be happy to know that internationally some countries have visited India's cyclone center at Delhi to assess our forecasting system so that they can utilize in their countries. So what I want to say that we utilize all the modern tools and technologies like satellite. You can see the picture of the cyclone here. This is the eye of the cyclone. This is the satellite picture. This is the radar picture. And also we have got specific modeling for different types of multi-hazards associated with tropical cyclones. For example, the tropical cyclone-induced tidal waves are predicted with the help of an advanced circulation model. The rainfall is predicted with a hurricane WRF model. And we have got different models, and models differ from each other. You can see here the cyclone file in forecast track 5 days ahead, how the models are differing from each other. You can see one model is going towards Visakhapatnam or weakening here itself. Another one is going towards Balasore. But finally, and this is another system called NSIM. So finally, the forecaster has to do the forecast. The cyclone forecast, the 3 forecaster will decide where the cyclone will go. And that will depend upon his experience, expertise, and interpretation of the model guidance. So you might be knowing that nowadays we provide 5 days ahead. We cannot say that 5 models are differing like this. I cannot give you the forecast. We have to give the forecast. So therefore, we give the forecast. And this is the final forecast you see 5 days ahead when models are differing like this. Forecast was issued by IMD. And forecast, red line is the forecast track. Black line is the actual track. You can find how accurate they are with each other. So that means the forecast accuracy is quite okay, helping the disaster managers to minimize loss of supply. This is the example of cyclone. Yes, this year you can see that again, the black line and red line. Red line is the forecast, black line is the actual track of cyclone. Yes, you see how on the past bulletin itself, on 23rd, when bulletin was first issued indicating the track, you will find that it was quite accurate, but telling that just south of Balasore, cyclone is passing Odisha coast. It will affect North Odisha in West Bengal. But the genesis of the cyclone in impact to Odisha was indicated by 19th itself. You can imagine. 27th, it crossed the coast. On 19th, it was informed to government of Odisha and West Bengal that a cyclone is approaching to your coast. Okay, so for flood forecasting, we have a combination of the approach with the Central Water Commission. And here, what we do actually, flood forecasting is the responsibility of Central Commission, Minister of Water Resources. We provide the heavy rainfall forecast and rainfall forecast. This quantitative precipitation forecast is provided for each and every sub-basin of the country, which is 153 in number. And these are utilized by them to run their hydrological model and hydrodynamic model. And hence, they provide the flood forecast. On the right-hand side, you will see that, and this flood forecasting purpose, we are issuing warning to them 5 days in advance. On the right-hand side, you will see that this is a flash flood guidance. This year we introduced last October, and this year also being provided. This is an example of cyclone Yas. All of us know that during cyclone Yas, how it caused the flash floods in the Balasore, Bhadrak, and Kendrapada districts during the cyclone passing the coast. And this indicates how the model could predict that the flash flood are very unprecedented rainfall there. There will be a combination of the tidal waves and the rainfall leading to floods in the coastal districts. Now, this is the example of the flood forecasting based on the IMD's rainfall warning for different river catchments. We have got about 10 river catchments under Flood Meteorological Office, Bhubaneswar, like Suvarnrekha, Budabalang, Baitarani, Upper Brahmani, Lower Brahmani, Upper Mahanadi, Lower Mahanadi, then Rusikulya, Bangsadra, and Nagavali. For all these, every day, twice, we issue the updated quantitative precipitation forecast during the flood season from May to December. Okay. Similarly, as Odisha experiences heat wave, entire country also will provide heat wave conditions. All this information, what I am telling you, the products are available in GIS format. So one can visit the IMD website and find the information. Just an example here, the information of heat wave, cold wave, temperature forecast in the GIS format. This is also provided in the impact-based forecast. We provide what is the impact of the heat wave, what is the comfortable temperature. And here also we work with our medical fraternity, Minister of Health, and their heat action plan has been established in the country for each and every district, especially central parts, and 20 cities at present, including Bhubaneswar, have the heat action plan, where the NGOs, Ministry of Labor, Ministry of Health, State Ministry, and also here, India Meteorological Department, Municipal Corporation work together to deal with the impact of heat waves. The thunderstorm, as I was telling that it is a killer, we have come up a long way. India is one of the 5 to 6 countries in the world who provide the lightning warning. From 2019, we are providing the lightning detection. You can find out where the lightning occurring now from the IMD website. You can find out from IMD's mobile app where the lightning is occurring at present, where the lightning occurred in the past 5 minutes, 10 minutes, 15 minutes. Also, you can find out where the lightning will occur during the next 45 minutes. So apart from this very short range forecast, which is called as nowcast, we also provide the forecast for next 3 hours. Which district or which city will have the lightning that forecast for next 3 hours. In 2 days in advance, we provide the hotspot, the area, the zone where lightning is expected during the next 2 days. So for this purpose, we utilize the lightning detection system, which has been established across the country by Minister of Earth Sciences and Indian Air Force, and IMD is writing that. We have got the radar systems, we have got the satellite systems, and the derived parameters. So this is just an example, this lightning prediction. You can just imagine every 3 hour lightning prediction. Odisha example I've just taken here. This is the forecast. You can see the lightning occur during this period. This is the forecast issued at 9 GMT. That means 14:30 hours IST of the day. And you see in the afternoon, the lightning occurred here. So this is the technology which has come up now, which is helping proper mapping and forecasting of lightning. And based on this, we are issuing the forecast. You can see here, 1,084 stations. Now we are providing the city-specific or town-specific information, and all the 739 districts are being provided forecast on lightning and thunderstorms and all severe weather events. So Odisha therefore have now the multi-hazard warning advisory for all types of weather events. I'll just take 5 minutes more to explain the agriculture specific, because Odisha is an agrarian state, most of the people depend on agriculture. So we have come up a long way. If you remember in the childhood, I was listening to Mangudi Bhai, if you remember, in the All India Radio, people believed that the radio is speaking. Nobody knew at that time that there is an organization called India Meteorological Department. And every evening we listen to Mangudi Bhai about the guidance for agriculture. But that has come a long way now. Now we are reaching out to 43 million farmers directly in the country, and in Odisha also quite a sizable number. We are also utilizing various platforms. But what we did then, we have established district-wise meteorological unit to address to the requirement of farmers. We have established block-level advisory for about 3,000 blocks. Some blocks includes Odisha also. We have come up with a public-private partnership. Many foundations like MS Swaminathan Foundations, Reliance Foundation, and many more, they have come up for dissemination of forecast. We have just like health advisory we are issuing for heat wave, we have also come up with the collaboration with Indian Council of Agriculture Research, Ministry of Agriculture, Agricultural Universities. OUAT is the nodal agency in Odisha, and also State Agriculture Department. So this is the success story where we have been able to provide the guidance and advice, which is an impact-based advisory to the farmers. So this is the way by which we are providing, as I was telling you, that it has a lot of collaborative work. There are many stakeholders working. We go for farmers awareness program, and we go for value addition to the farmers' requirements through this KVK and Kisan portal, Kisan call centers, all are working together. And it has resulted in 50,000 crore economic benefits because of this service, joint service, of course. And we have found out that people believe in this service. And this is the agro advisory services in the Odisha state. We have got KVKs, Krishi Vigyan Kendras in different parts of the state. And through this, we have got the agro-meteorologists and agro-met observers, and we have got agro-automated weather stations. We have got additional observations as required for the agriculture purpose. And through all these collaborative agencies like ICAR, ISRO, OUAT, KVK, State Department, ORSAT, IIT Bhubaneswar, we have got a very good combination of the talent, and with that, we are reaching out to farmers. So these are the various types of specific products which are generated for the agricultural purpose. I will not discuss much, especially, for example, evaporation, potential evaporation, evapotranspirations, which are needed for agriculture, soil moisture, soil temperature. So these are products generated, which are used in numerical modeling, and also which are used to assess the impact of agriculture. So once all these information is there, we transmit all these information through an end-to-end early warning system. It goes to community, and also it goes to the various disaster management authorities like NDMA, SDMA, DDMA, State Emergency Operation Centers, and many more. Our objective is to reach out to the rural villages and communities. And for this purpose, what we do actually, we utilize mass media. We are utilizing WhatsApp group like that, social media, and also the existing network of each state government. For example, Amakusi. Amakusi is a very good network of state government of Odisha, which is also being integrated with the bulletin issued by India Meteorological Department. So these are the important bulletins issued by IMD Bhubaneswar. You will find out there are 10 to 15 bulletins issued every day for different purposes. And when there is a cyclone, there is a specific bulletin, and that all of us know. I'm not going to discuss here. We go on a very systematic way with pre-cyclone watch, cyclone alert, cyclone warning, post and outlook, T-warning. Like this, for heavy rainfall, also we have started for last 2 years, like heavy rainfall watch, heavy rainfall alert, heavy rainfall warning, and D-alert for heavy rainfall. Okay. So if you see the warning dissemination system, you will find that we maintain a redundancy. We have got the various websites and web platforms. We have the information in regional language. MC Bhubaneswar is doing excellent work by providing the video information in regional language and also the audio informations. And also you'll find that all the information are text come graphics. You will find the press release also in Odia language from our MC center. We also come up with the mobile apps. You will find Mosam for general weather, Meghdut for agriculture, Damini for lightning, and Rain Alarm for rainfall, Umang, which is popular mobile app for the government of India. There also you'll find weather informations. We have the social media handle, Facebook, Twitter, Instagram, blogs. and we have got Twitters. You can find out all these. We have also a blog page, and all these are helping to reach out. So this is just a representation of all types of. We have got the APIs. All the state governments are utilizing the data from IMD, utilizing this API. We are also part of the Common Alert Protocol, which is being organized by the Government of India and is experimented. Most probably next year we'll have Common Alert Protocol. So this Common Alert Protocol, there is provision to reach out each and every person, whether you have got a smartphone or whether you have got a simple phone. You can get the information if you go through Common Alert Protocol. And also you'll get information through common regional language, English and Hindi. We're also reaching out to the global community like United Nations or UNDP, UNEP, through this global multi-hazard alert system. We provide a global multi-hazard alert system occurring over South Asian region. We support all the countries in this region by providing the alerts. So these are the three apps. I will request all of you to download these apps. It is available in Android and also in iOS. And it is very helpful, especially for daimining. You can find out whether lightning is occurring or lightning is likely to occur. You can find out for any other station also. You can just type the station name. You can find out the warning for that. And recently we have gone for the crowdsourcing. So what do we feel that weather is such a phenomena where all of us should work together. So every person or every human being is a weather forecaster. Just imagine when you get up from the bed, we always look at the sky. We believe that morning shows the day. If it is sunny, we say that, okay, it is fine today. But certainly morning shows the day is not correct when you go for nowadays the weather conditions. So what do we feel that the crowdsourcing, that means each and every person can be a source of the information. We have developed a web platform, also developed a mobile app through which people can report the weather, what they are experiencing. So for example, you are at your home, you found that it's raining. You can just go to IMD website and enter there. You have to just tick mark. You have nothing to write. And your geotag, you will get the information where it is occurring. And that information will help us to give nowcast to other persons. It will help us to provide the validation of the numerical models. It will also help us to assess the forecast issued in the past. So these are some of the social handles by Meteorological Center Bhubaneswar. You can find out Twitter at the rate of MCBBSR. You can find out the Facebook. You can find out the website for Meteorological Center Bhubaneswar. So I need not mention here that due to all this technological improvement of weather forecasting and warning services, there is a significant improvement in accuracy. You can find out that how accurate is the cyclone forecast. Similarly, heat wave and monsoonal heavy rainfall. At present, our forecast accuracy for heavy rainfall 24 hours ahead is 80%. But there is still 20% chance. And similarly, if you just look at about thunderstorms 3 hours before, if I say it is 85 to 90%. So this accuracy has helped to minimize the loss of lives. You can see that loss of life due to cyclone has been minimized, loss of life due to heat wave has been minimized, and loss of lives due to heavy rainfall has also been minimized. So still there are challenges, and we have to improve further to bridge the gap so that we can improve the forecast accuracy by 20 to 40% further. It is planned that by 2030, MOS strategy document says by 2030, we will have the improvement of further severe weather warning improvement by about 20 to 25%. So how will you do that? So there are the concept we are utilizing that is called a dual engine concept. So one engine will have the numerical modeling, that's called numerical weather prediction modeling with the help of the high performance computing systems. At the same time, we have got a lot of data. People talk of big data. I am the source of big data long back. We have got data from satellite, we have data from radar, we have got data from observational systems. So the artificial intelligence, machine learning, deep learning has a big scope to utilize this big data with the cloud computing and the high performance computing systems. So we are approaching for dual engine now with public-private partnership and to have a solution for improving the forecast accuracy further by 20 to 50%, 20 to 25% by 2030. At the same time, impact-based forecast, which have started for the last 2 years, will be improved further. And that will help to minimize the loss of properties in addition to the loss of lives minimization. So thank you very much.
Thank you.
Thank you, sir. Thank you very much. And then I was just checking out. There are only, I think, 2 questions are there posted through the chat box. And Mr. Dr. Panigrahi.
Yes, Jai Krishna.
Krishna Panigrahi, he has asked.
Yeah, so shall I respond to the questions? What is written in the
you have read it, sir?
Yes, I have read it. I have read it. So his question is about the greenhouse gases. Yes, the greenhouse gas has resulted in this global warming, and we have seen that there has been abnormal rise in temperature. Temperature increased by about 1 degree Celsius, 1.2 degrees Celsius globally, and over the country it is 0.66 degrees Celsius. And so because of that, yes, he has written about the temperature and the troposphere. Yes. So once the troposphere is expanding in terms of the temperature, certainly, as I was telling, that water holding capacity is increasing, temperature is also rising. Therefore, the occurrence of thunderstorm requires 4 parameters. One is that there should be heating. The second one is that there should be moisture. And third one is that there should be triggering mechanism. The fourth one is that there should be some kind of uplifting. So therefore, since the 2 parameters like increasing temperature and increasing moisture are favoring in the scenario of greenhouse gas increase or global warming, the thunderstorm frequency and lightning is expected to increase.
Mr. Padhi, he has asked a question that why the sky is changing due to this atmospheric and other factors. So kindly throw some more light on it. That's the general question. Yes, this time.
Yeah, the sky is changing in the sense that if you are in a rural village, you will find that if there is no cloud, it is a very blue sky. Okay, it will completely deep blue sky you can see. But if you come to some industrial belt, for example, if you come to Delhi, you will never find a blue sky. It is very difficult to find a blue sky. It is basically because you have got so much of aerosols, the man-made aerosols, which are coming up because of the industrialization, urbanization, and many other sources. That goes into atmospheric loading. The aerosol loading increases in urban areas, and as a result, the sunshine which is passing through, it gets absorbed or reflected, and therefore you cannot get the blue color of the sky, which is the case in case of rural areas. So that is the reason.
Vivek Patnaik sir has asked a question.
So there's one thing I can add.
Vivek Patnaik has put a question through the chat box. Let us first.
My question has not been fully answered, Dr. Mohapatra.
Let us. Time is very short.
My question was please. My question is, see, I am an ignorant person. See, the sky, what I see over Bhubaneswar, the whole spheres or layers and all that, they are moving along with the world when we rotate and we rotate around the sun, everything. Are they not changing? Are the same sky is there for last 20 years? I doubt.
No.
That ground. Okay. That aspect, that was my question.
Yes, it is changing. It is changing. So there has been change with respect to the concentration of the aerosols. There has been change with respect to the cloud content in the atmosphere. There has been change with respect to the moisture content in the atmosphere. As I was telling, if there is a rise in temperature by 1 degree, 7% moisture will increase in the troposphere. So therefore, these are the changes occurring everywhere. At the same time, the atmosphere, the sky, whatever we are looking at over Bhubaneswar, that is not constant. It is dynamic. If you look at the weather scale, it is moving. The atmosphere is moving from one part to another. Therefore, sometimes you're getting blue sky and sometimes you'll get the cloudy sky. So that is because of the movement of the weather systems, etc. But in the long term, if you just look at whether the sky condition is changing, yes, sky condition is changing over different parts of the globe. If you filter it out, the cloud parameters, and you keep it the various types of greenhouse gases and the aerosol parameters, you find that basically the cloud, basically these aerosol particles are obscuring and leading to the degradation, and you are not finding the blue sky.
Yes.
Sir, let me read out the question of Vivek Patnaik sir, then I will come to you, sir. The extent of which Vivek Patnaik's questions. The question is.
Yes, I got the question. The extent to which standards and practices followed by WMO are followed in weather forecasting. Yes, WMO is the international agency to ensure the standards. And within the country, the standards with respect to observation, standards with respect to modeling, standards with respect to forecasting, and unwinding services. Now, I will go one by one. For observations, long back in a pre-independence period, Rainfall Registration Authority was established in the country, and IMD was given the responsibility for registration of rain gauges. So whoever company comes up with manufacturing of rain gauges, they get certification from IMD. At the same time, if you go to establish one rain gauge and you want to report it internationally, that has to be certified by IMD. And what is happening nowadays, actually, many private companies also come up and they put up the rain gauge anywhere without going by the standard of WMO. So therefore, what we do actually, we do not consider all these rain gauges. We consider those rain gauges for monitoring of rainfall, which meet the standard of the World WMO, World Meteorological Organizations, in terms of the exposure conditions and etc. Similarly, if you just look at other sensors or the instruments, there is standard calibration rules, validation rules, and also there is the standardized error which is specified for a given sensor or given instrument. So we follow that. As government agency, we follow that. And as for that, we go for inspection, calibration in periodic manner to ensure the quality. Similarly, if you just go to the modeling, yes, in the numerical modeling, there is a standard practice. In the standard practice, all are the party to it. There are around 185 countries which are member of the WMO. There is understanding internationally. You need the data exchange. You need the quality data. So we ensure that. The upper atmospheric observation, for example, if it does not meet the standard of WMO, it will not be utilized by the international bodies. So therefore, country, India, we have to ensure.
Can I ask a question, sir?
Yes, please.
Prasad Rai, Devi Prasad Rai.
No, actually, because I was very much associated with IMD since long, because I was the Vice Chancellor of OUAT. Because IMD is doing a wonderful job, and ultimately for agriculture planning and other things, it was very much helpful. At least after Cyclone of 99, that I can say in Odisha. Actually, we started also with the help of Dr. Bhavan, who was at Delhi IIT, and we started one PG department in meteorology also in OUAT because of its importance. Actually, my thanks to the Professor Mohapatra. He actually has given a very good talk, and IMD is very much helpful for making agriculture planning, and also because of their weather cost and timely weather cost and timely planning and all these things. Because in ICR system also, because we had one NICRA project and All India Coordinated Research Project on Climatology, we have done a lot of work. Dr. Venkateswarlu, who was working at Hyderabad and Dryland Institute of ICR, and ultimately in every district also, as Dr. Mohapatra mentioned, that we are having a Krishi Vigyan Kendras and we are having...
Sir, please ask the question, sir. Time is, we appreciate.
And whatever Mohapatra has told, it is very much beneficial. And he is doing a wonderful job. It is actually from the Odisha, and ultimately it is a very proud of us. Thank you, Dr. Mohapatra.
Okay. Mr. Subhamai Beura is asking a question. There are different types of lightning types seen in different literatures. What factors are responsible for these types and its intensity, and which type is much dangerous? That's the question.
Yeah. Actually, we get three types of lightning. One is within the cloud. So what happens during this cumulonimbus or thunderstorm cloud, there are two types of movement, the updraft and the downdraft of the particles. So when there's updraft, for example, when we, a child, what we do actually, we do like this and put off in the dry paper, it picks up. So that's the static electricity. So within the cloud itself, because of this updraft and downdraft, there will be static electricity, and hence the separation of charges, the electric current flows, lightning happens. At the same time, one cloud, thunderstorm cloud, generates another thunderstorm clouds nearby. So therefore, between the clouds also there will be charge separation, and hence there will be cloud-to-cloud lightning. The third one is that Earth's surface is also the charged surface, and therefore there can be difference of the charges on the bottom of the cloud and also the Earth's surface. So the lightning flows, the electricity flows, and electric current also we get. So therefore, three types. One is the within the cloud, other one is the cloud-to-cloud, and third one is the cloud-to-ground. And cloud-to-ground lightning is quite dangerous, and I want to say that out of 7 lightning, one is the cloud-to-ground lightning, the frequency. But even then, that cloud and lightning is most dangerous.
And Mr. Omkar Mahanti is asking this: is cloud seeding is extremely low rainfall periods being contemplated?
Yeah, cloud seeding has been attempted for a long time, actually 20-25 years in the country now, and especially it is done in Maharashtra, interior Maharashtra, and also in Karnataka and sometimes in Telangana. So in case you have got clouds, which is not much rain bearing, you can go there, you can put silver iodide or some kind of hygroscopic nuclei, and you can have rain. And we have seen that, yes, to some extent, it can increase the rainfall activity. But whenever you have got much amount of clouds, for example, monsoonal clouds over Odisha in Western local systems, there is no point in going for. So therefore, usually, this cloud seeding is carried out over a region which does not get much cloud and which does not get much rainfall because of that. So Deccan Plateau, therefore, is preferred for this artificial rain making.
Another thing, one question, Sodeshu, to Dr. Mohapatra, just a clarification. Because the humidity is increasing day to day along with the temperature. What is the solution, Dr. Mohapatra?
Solution is we have to cope up with that. So we have to minimize the source of greenhouse gases. Even if you minimize now, also the life cycle of these greenhouse gases also will take 50 to 60 years. So at least for our next generation, we can ensure that their environment will be better if we can minimize the source now. The second point is that the sink, where the substances which absorb these greenhouse gases, for example, the forest, the tree cover, they absorb this carbon dioxide. So therefore, we should increase forestation, we should preserve this one. Otherwise, there is no other way to go.
Sir, I think it is past 7. Should we now call it a day, followed by huge vote of thanks?
Sodeshu, more chat box देई देखंतु.
Chat बाजिछ परा.
Chat box देई पढन
आपण किछि प्रश्न पचारिबे कि? प्रश्न पचारु ओनली पॉइंटेड प्रश्न.
ना ठीक अछि. बहुत सुंदर वक्तव्य रखले मृत्युंजय बाबू, धन्यवाद. मोर प्रश्न आपण एडवांस अर्ली वार्निंग फोरकास्ट सिस्टम निश्चित भाव में साहाय्य करछि शॉर्ट टर्म रिलीफ मेजर पे. लॉन्ग टर्म रिलीफ मेजर पे ओडिशा पे कोन आपण सजेशन देबे?
ओडिशा आपण जति कहउतिले ओडिशा हो गोटे बात्या बन्या दुर्विपाक प्रवण राज्य. सब प्रकार दुर्विपाक देखा जाए. तेणु आमर लॉन्ग टर्म प्लानिंग रही जे केमिति हमें ओडिशा रे ऑगमेंट करबा ऑब्जर्वेशनल सिस्टम को. एबे हमर 2टी डॉप्लर रडार रही आउ 2टी डॉप्लर रडार लागियो बालेश्वर एवं संबलपुर रे नेक्स्ट 2 to 3 इयर्स भितरे. या सहित जो ऑटोमेटेड वेदर स्टेशंस रही ताको मध्ये ऑगमेंट करा जिवो एवं ऑटोमेटेड रेन गेजेस मध्ये ऑगमेंट करा जाउछि. आपनकर स्पेशली भुवनेश्वर कटक सिटी पई मध्ये अर्बन वेदर सिस्टम फॉर भुवनेश्वर कटक सिटी मध्ये निया जाउछि कंबाइंड प्रोजेक्ट रे. सेति पई स्पेसिफिक फोरकास्ट प्रोडक्ट डेवलप करा जिवो. एयर क्वालिटी इंफॉर्मेशन मध्ये सेति दिया जिवो एवं वेदर फोरकास्ट मध्ये दिया जिवो. एवं या सहित आपनकर जो स्पेसिफिक सेक्टरल एप्लीकेशंस रही आपण जानिथिबे आमे वर्तमान मलेरिया नो मोर गोटे कैंपेन करा जायछि. जने एनजीओ एवं हेल्थ डिपार्टमेंट गवर्नमेंट ऑफ ओडिशा एवं आईएमडी क्षेत्र इन्वॉल्व होछंती. आमे वर्तमान प्रति आमे ओडिशा रे बहुत लोक मलेरिया रे मृत्युवरण करछंती. तेनु ओडिशा को वर्तमान टारगेट पायलट सिस्टम नै छु जे किमिति आमे मलेरिया पे फोरकास्ट दे परिबा. मलेरिया डेंगू ए मध्ये फोरकास्ट दिया जाउछि. मलेरिया डेंगू एक्सपेरिमेंटली ताको किमिति स्पेसिफिकली विभिन्न अंचल पे दिया जिवो व्यवस्था करा जाउछि. तापरे आपनकर ट्रांसपोर्ट नेशनल हाईवे स्टेट हाईवे रेलवे समस्त पे फोरकास्ट इंट्रोड्यूस करा जाउछि. आपनकर एनवायरमेंटल फोरकास्ट मध्ये दिया जिवो. हाइड्रोलॉजिकल सेक्टर आपन जो फ्लड्स बेसिकली आपन ओडिसा रे जो देखछन्ती 10टी रिवर कैचमेंट रहिछि सेति मध्ये आमे वर्तमान एही वर्ष ठारू 3 दिन 5 दिन फोरकास्ट मध्ये देइछु. ताको मध्ये किमिति ऑगमेंट करा जिवो सेते माने एक्सटेंडेड रेंज फोरकास्ट केयर लेक मध्ये फोरकास्ट करा जे परिबो. सेति पई स्पेसिफिक मॉडलिंग किमिति करा जे परिबो ओडिसा बेसिस रे आमे वर्तमान जो मॉडल रन करछु तार रेजोल्यूशन होचे 12 किलोमीटर 5 किलोमीटर पर्यंत आनिबा. जेमिति कि आमे हाई रेजोल्यूशन नै कि आमे जो वर्तमान डिस्ट्रिक्ट लेवल ब्लॉक लेवल दउछु पंचायत लेवल किमिति जाई परिबा विलेज लेवल किमिति इंफॉर्मेशन दे परिबा. सेटा होचे अपन नेक्स्ट प्लान. तेनो 3टी कथा हम कहबी. 3टी एथरे मते बिंदु रहिछि. गोटे होछि जे किमिति आमे हमरो नो वेदर गोज अनडिटेक्टेड एंड अनप्रेडिक्टेड. ये होछि फर्स्ट पॉइंट. मुझे चार्ज से सेटा मते कहितली रिपीट करछि जे कोन से डिजास्टर अनडिटेक्टेड हेबो नै कि अनप्रेडिक्टेड हेबो नै जे परि कि लॉन्ग टर्म प्लान नै जाउछि. आ गोटे हूँ जे इम्पैक्ट बेस जहाँ हमें देबू तार इम्पैक्ट फोरकास्ट मते करिवु से डायनामिक इम्पैक्ट फोरकास्ट करे मते व्यवस्था कर देछि। तृतीयटी हूँ जे कहते हर हर मौसम घर घर मौसम माने आम चेष्टा करूँ कि प्रति घरे पाणीपाग विवरणी पहुंचवा दरकार तमाने डिसेमिनेशन सिस्टम केमिति आम पब्लिक प्राइवेट पार्टनरशिप रे पहुंची समस्त पहुंच परिबा एवं प्रति समय प्रति घंटा इनफॉरमेशन केमिति बर्तमान दे परिबा। आम बर्तमान 36 घंटा में प्रकाश हर एवरी आवर दिया जाउछि एवं विभिन्न सिटी पे दिया जाउछि किंतु वर्तमान सब जगह में पहुंचवा दरकार सब लोक पार मते पहुंचवा दरकार। तापर सेक्टरल एप्लीकेशन जहां कहले तक मु रखितली 7टी सेक्टर में आइडेंटिफाई करिछु से सेक्टर रे केमिति हम एक ऑगमेंट करके हम सोशियो इकोनॉमिक कंडीशन पे इंप्रूव करि परिबा। ए चारटी हमर लक्ष्य रही छै।
Mr. Onkar Mahanti, I would take a question. By and large, one finds that while the cyclone predictions capability with numerical models has improved, the weather predictions capability seems to have gone down due to global warming. Are we planning greater number of data accumulation?
Yes, sir. You have told correctly. I have given in my presentation also. The global warming limits the predictability. So, solution to the question raised because of the global warming is to augment the observational systems, to augment the modeling systems, so that you can have the better forecast to address to these mesoscale weather events like heavy rainfall and thunderstorms. It may be embedded with a cyclone, it may be embedded with low pressure system or a depression. It has to be addressed. So for this purpose, we want to augment our observational network, as I told you. We'll augment our global modeling so that we can go from existing 12 km to 5 km. We'll augment our mesoscale model so that we can go from existing 3 km to 1 km or less. And thereafter, we have to go for impact-based forecast. This is a dynamic platform. That means we will be needing the data of the socio-economic conditions like population density, house, roads, bridges, culverts, railways, national highways, airports, all industries. So all this data should be digitized, and that digital information will be superimposed with the weather informations, and also it will have the information about secondary hazards like landslides or landslips or land sinks or the floodings, so that we can have a very granular assessment of the impact and the risk. So for example, if I am telling now, Bhubaneswar will be a heavy rainfall, instead I should tell whether it will be Panibihar or whether it will be Oyueti or whether it will be Master Canteen or which slum will be inundated. That type of information, if I want to give, I need the support from the government, support from the various NGOs, academics, R&D. It is not possible by IMD alone, because you need a huge amount of data from socioeconomic indicators, geophysical indicators, meteorological informations, and secondary hazard informations. We are working in that. That has been achieved for cyclone. Now we are planning for heavy rainfall, and heat action plan has been in that directions. So I hope during the next 5 years, we will come to that type of stage where we will have a dynamic impact-based forecasting, risk-based planning in a very granular manner in village level and the world level.
Thank you, Dr. Maharaj. Thank you.